think it's working. Just waiting for it to start. Let it go for time. We'll be here. Hello. I think it's working. Just waiting for it to start. Yeah, it's working perfectly. And so you're okay. Hi everyone. And if you're watching for the first time, let me tell you. So, welcome to the High Entropy, and this is our day 37 of DSA learning. So, I'm just on a mission to build endurance and so show up every day so that you can show up right? So every day you have to come up and show your presence, and also like you are building and you are learning something, and that's why I just started streaming so that I can be consistent. And this is one of the reason of my queue, or you can say. So right now I'm reading a book, Atomic Habit, and there it is mentioned like if you want to make something as a your habit, then you have to start it daily, and for that you need some sort of motivation, and streaming is one of the motivation. It feels like someone is watching and I need to narrate it in a proper way, though still I'm struggling, but I'm on the way. And if you are also feeling like you are not consistent, then just try to find out something that motivates you. It could be streaming, it could be making recording videos, or if it could be like you are in college or school, wherever you are and whatever you are doing, just try to find out the reason why you want to do something, and it will be more fun, and you will it will become your habit. That's why it's been 37 days, and every day I'm coming up and showing up my presence. Even if I'm working, then I'm just keeping it aside the work for 1.5 hours, and I streaming and I'm going back. So that's how it's pretty good. Like when you are doing something and you associated it with some sort of reward, and reward is nothing but great. That one day I'll become a good streamer and all. So it's like a kind of now I'm just not getting immediate reward, but I'm expecting, and because of that expectation, I'm passionate to learn DSA. And also like you know the benefits of learning DSA. Definitely your logical skill will be built up, will build, like you will be able to solve the DSA problems. And it's not about DSA, you like when you will solve some problem, it's about logical thinking as well. Like you will become good at logical thinking. And only DSA is not enough for the anything right now, because the job criteria and everything got changed. And let me come keep everything aside. And what is in my bucket right now? So where is my, okay, 1 minute, man. I think something is wrong here. Actually, where is my that one? Oh, I just closed, man. That's problem. I mean, I just need to do something. First, I need to open a. Here, if you notice, I have 20 subscriber, and that doesn't matter like whether I have 220. Matters is consistency. Because if you will be consistent, you might get what you wanted to get. It might take time. You will sometimes, you know why everything is very important. When you are in the learning path, it's not about the work, the things that you are doing. It's about everything. Like you, it's like the way you are speaking. You will try to mm, refine yourself. Like when you will not get views and all. I'm not preaching or I'm not giving anything. I'm just trying to tell you like everything that you are facing or whatever you are getting, it's learning for you. If you are not able to solve DSA, you will try out different methods. Okay, this is not working for me, then you will, and that's the learning. So everyone has different curve. If you solved any machine learning problem, you know like what how training occurs. It's like it try out all the options, and if you know brute force approach, so we have our brain also tries to try out different options, and that the best one that is the best one that is working for you, that become your niche. It could be like there are so many YouTubers that started with something else and they are doing something else because they found like people, this is best for me, or people are more engaged in this niche if I'm working. So that's all. So that's why it's always you are learning. Nothing is here like always. Whenever you are doing something, you are learning. Either you are getting experience or getting reward. So, oh, 1 minute, man. What happened? I think it logged in. Hey, come on. I know you can see my email. That's not a problem. That's email, not my personal number. What? Okay. So we are in the binary search, and we are in the last section of it. Yesterday I was trying to solve a problem and I wasn't able to solve it. We find a peak element, and let's jump into the problem. I don't want to waste your time or something, so let's jump straight to the problem. Okay, I think that's the perfect sentence. I think, I do not know, maybe let me know if you know better what needs to be said. Okay, so we have given an array, given a zero indexed n cross m matrix where no two adjacent cells are equal. Okay, no two adjacent cells are equal. That means, okay, find any peak element mat ij and return the array ij. A peak element in a okay, so it is given like a given zero index n cross m matrix where no two adjacent cells are equal. Okay, so all are different. Basically, values that are neighbor to a particular cell will be different. All neighbors will be different. Okay, that's great. So that's why it will be peak. No. Okay, now the thing is like you need to find out that definitely it will be greater than, strictly greater than, that is all automatically following, because if you know, here we are saying no two adjacent cells are equal. So if it's not equal, then it's strictly greater than that. We don't need to check, just we need to check if it is greater than that. Neighbors of to the left, right, top and bottom. Okay, assume that the entire matrix is surrounded by an outer primer of perimeter, not my bad, perimeter with -1 value. Okay, that means if you are considering any value that is in the boundary, then that definitely that will be greater than, and I hope all the values are greater than are equals to 0. Yeah, you can see all the values are greater than 1, even greater than or equals to 1. So that's why if you will take -1, definitely all the values will be greater than, so it will satisfy the condition for boundary as well. Okay, the primer with value -1 in each cell. Oh, okay. First, let me note down. I don't know what will be the solution for it. Just we are going to try out. So it is 10. We have 10, 20, 15. And then another one is 21, 30, 14. So here nothing is sorted. So for sure. Ten, 7, 11, 17. Okay, let's try to solve it. What needs to be found? Find any peak element. Okay, great. So if we'll start, I know there is one option like you can brute force. Brute force would be something like you can start with any element and just try to check its neighbor. It will be like -1, -1. So that's why if it is in this one, you don't need to check all the boundary conditions. Just check this element and this one, and you can assume blindly that this will be peak. If it is greater than this, its neighbor, available neighbor, you can say. So you don't need to check other ones. Maybe just assume. Okay. So the thing is we have given numbers and we wanted to, yeah, so we have given numbers and we wanted to find out the any peak element. If you notice, this is the peak. What is the value of it? 14 or 54? 14, man. seems like 454. Okay, so definitely we do not know whether the number is can be greater or bigger, very definitely. But if the number is always will not be equals to, that's for sure. So based on that, can we say something? No. So suppose if we'll start with this number, then what is the uh, condition for it? If this number is not greater than the other numbers, I'm just thinking like if you remember like last time we saw the peak element, and we were sure like if the number is if the next number is bigger than this, then it definitely. Oh, let me try to implement from that perspective. If you know, like last time we solved a problem where we were saying like something, numbers are given, all the numbers are different, so definitely if this will always be smaller than the number, and we were trying to find out peak element in 2 day 1 day array, and that's why if the number here we are checking if the next number is, if it is small, is bigger than this number, then you know what, if it is bigger than this number, that means there will be peak and we can go in this direction. You know why? Because if it is not peak, that means someone will be bigger than this, otherwise it will be peak, and otherwise it will be peak, and in the finally you will get peak. Okay, because the last one definitely will be peak. And if you are getting here some number bigger than this, okay, I forgot the man what. Yeah, so this is one condition, and here also you will see -1, right? If it is smaller, then it can be peak, and if this one is smaller, suppose let's say this is smaller, so it cannot be peak. But if this is larger, okay, if this is larger, then definitely this one won't can't. That means if it is larger, it is larger, and then you can say like okay this one. So anyone if it is larger, then you can say, and otherwise the case is like one will be larger, one will be smaller, and definitely you will get the pack. Here also we can follow the same scenario, I hope. Suppose 10, we need something like a 10 should be bigger than its neighbor this direction, this, this, and this. But if it is smaller than something, so what needs to be done? Suppose it is smaller than this number. So this can be a peak element, right? Can be peak. Can be peak. If it is smaller than this can be peak. This can be peak. This can be peak. Okay. But what if this is smaller? Small. So definitely this one will, it will take move towards this direction. But will it be feasible something like what I'm doing? Okay, let me think more properly. Notice there can be many peak values. One is given as output if the return index is peak number. No two adjacent cells are equal. Okay, that will satisfy one condition, man. Think more. Speak less, think more. Speak less, think more. Speak less, think more. If we are talking about this is smaller than this number, smaller than this number. So definitely this is not going to be peak element. So we have two options, right? Either move in this direction or move in this direction. So what should it do? Both are potential you can say element, this one and this one, I believe. So here isn't any scenario. If we'll jump to this direction, maybe let's say 20, and we'll say 20, 10, 20, 15. So both are smaller. Definitely we don't need to check this one already we checked. So we can say, or maybe you need to check also, we'll see. And this one also you can say it's a smaller, man, my bad. And this is bigger number, and this is a smaller number, so definitely we won't go this direction. And we can say this is bigger number, so we'll jump into this number and we'll see. Okay, again, so this is bigger than this, and we need to check its surrounding. So it's bigger than this bigger than this, and bigger than this. So we got the number. But suppose what if we took 21? 21, then what will be 10, you move to 21. 21 you will check, okay, it's bigger than this, and bigger, no, not bigger than this, so you will move toward this direction. But cannot be case. I was thinking like what else is possible. Suppose here we are taking, so we will start with this one number, and we'll say okay 10. What are the neighbors of it? This will say 7, so it's not going to help. So 7 is a smaller number, then definitely okay. 7 is smaller, then okay. We can't move this direction if it won't work. I mean, if we are not getting this as a peak, then it won't go this direction. It will say here what are the possible options of a number. It could be either bigger than all, or it could be something else. What else? I mean, it could be larger, bigger than all, or it could be smaller than someone. So there will always be a chance of getting bigger than the number, so we can move towards that direction. So for example, it will go in this direction. 11, you will say this is bigger than this already. And this, it will say no, it's not bigger than this. Then it will jump into this, and it will say okay, bigger than this, bigger than this, bigger than this, bigger than this. So yeah, it will be one possible options. Okay, I'm just trying to deduct, not deduct, bro. What are you saying? I mean, I'm just trying to reduce the problem so that I can get something from it, based on the what I solved yesterday, or what I learned from the last problem. I think I'm about to get the solution for it. So I'm pretty close to it. I'm just trying to do, just checking if there are any corner cases. So we'll start with 0 and 0, and every time just check, like wherever we are. So we'll create a function check if possible. If possible, that is okay. Else, or what it's going to do. I just want to if not, find max and move towards that. Move towards, not move, move towards that. What color you are choosing? Green. I don't know if it is highlighting to you or not, man. So okay, so every time what we'll do, like wherever we are, we have two steps. I mean, we are here, for example. So it could be like we came from this direction, or we came from this direction, right? Because we are moving from this direction. So okay, and where we can go, either we are going to move in this direction, right, or towards bottom. Every time what we are going to do. So can I say every time I'm going to travel in this direction or in this direction? So if I'm going to travel in this direction, what is the maximum value that I will travel? Can I go in the back direction as well? Let's see. If I'll go in the back forward direction only, then that will be like m plus n. But what are the cases? Like for example, we will check this first element, and we'll move in this direction or in this direction. Then suppose we checked this one. Okay, so this is small. Let's say we move to this direction. Now we have two options, either move this direction or move this direction. Let's say we move to this direction. Yeah, okay. And there are other options, like maybe we move to this direction. Now this number is bigger than this number. Okay, this one is also bigger than this, and this one is also bigger than this number, right? It could be possible, right? I mean, definitely this number is smaller than this. If it is smaller, then only we are moving, so this is bigger. Plus, we can say plus 1, or but what about it? It could be like this is bigger, but all the elements, this one is bigger, and this one is bigger. I'm just thinking, what could be the, in worst case? Maybe let's take example of it. Okay, let's take like we are not moving towards back direction. Then what will happen if we are moving forward direction? Can we, like, can we be sure that we'll get result? That's what I'm thinking. If this is bigger number, okay, this was also bigger number, and now let's assume there are two scenarios. This is a number, and this is a boundary condition. This is bigger number, bigger than this, and it decided to move in this direction. Okay, so what will be happen? Now this number is bigger than this, and here we can see this is bigger than this peak number. This is bigger number. Let's say this is bigger than this number as well, and bigger than this number, so this is big. Definitely we lost, like we can get from here, but we haven't moved toward this direction. But let's say, but what happens if we feel like this is bigger, this number is bigger, so that this can't be peak. Okay, but what if we are going to this in this direction, let's say? Okay, there are two options, like here either go, or in this direction you should go. So we have two options. And what if I'm just making worst case scenario? If suppose this is smaller, this is big, small, this is big, and this number is bigger than this number, so these two are supporting small, big, small, small, and this is big number compared to these two, and this one also, but this is bigger. So definitely I do not have any option to go to top or bottom. I mean, I have to go towards bottom, to this direction only. So it's like you have to choose. But if it is big, man, it's like you will be trapped into complete array. No, man, it won't help me if I'll go in this direction. Suppose this is big number, and this is also big number. Yeah, it's possible, right? This number is big, it was small. But let's say we have got into this rank where this is big, and we got into this. Man, something is wrong. I'm not coming up with the approach or what. So big, this is bigger than this, and this is a small number, so this is bigger than this. But here suppose we got big number, then it won't be the case. If this is bigger number, then that means we need to move towards this direction. So based on this, it seems like I will to travel all the possible options, and that I don't want to do. If we are traveling in all the direction, that what is the meaning of binary search here? Come on, man, you are not solving it in a proper way. Let me try out all the other options. 10, we can say like we have two options, 10 and 21. So why should it go towards this direction? It can go in this direction as well. 21. Okay, so I think I need to check. I need to come up with a solution. What is the possible options that we have right now, so that we can cover like in the forward and downwards direction. So here, oh man, what I'm thinking. So here we have two options, like either go in the back direction, down direction, or in the forward direction. So what would be the best options, like if we wanted to cover more numbers? Oh, okay. So if we are moving forward, then also like if we wanted to cover this number, we have to move backward. We have to come again back towards back direction. Come on, man. Okay, I get not working. Come on, what's wrong with me? 10, 20, 15, 21, 30, 14, 7, 16, 20, 32. Something I'm missing. I mean, we are literally 1 minute. Let me read again. Problem. Given a zero indexed n cross m matrix where no two adjacent cells are equal, okay, find any peak element matter I and return the array ij. Peak element in the 2D grid is element that is strictly greater than all of its adjacent neighbors on the left, right, top, and bottom. Okay. I'm just thinking. Okay. Can I come? I think something I'm missing. Some property is missing. So if we are starting from there, or is there any property that I'm missing? Like a. I mean, earlier what we did, or in the previous problem, what we were doing, like we were skipping, skip row or skip column. I just is bad on my screen. It's bad. I was just skipping row or column. But can we do this here also? If we'll start with this number can I say like this row cannot be the bigger number? If this is bigger number, then it could be one possible case, and 15 could be also possible case. And what else we can do? Maybe we decided to move in this direction, and if we'll not find this and this number is bigger than this, or the below one will be bigger than this, then the problem is we are missing this number, right? I always forget. I don't know what. I'm not able to solve. It's been 3-4 days and I'm just watching solutions. No, I don't want to watch. What is time? 9-5. Come on, man. Given a zero indexed n cross m matrix where no two adjacent cells are equal, find any peak element matrix and return the array. I say peak element in 2D grid is an element that is system. I think some common or something are missing, man. Come on, man. This is a number. Okay. So this is a number where like I'm just starting from this number, and what we are our steps, two things. It could be this number if it is big. Big. Now I decided to move. Either I'm just deciding like can I do this for sure? Like I'll get. I just need to find a peak element, and I need for that I need to be sure. So I'm just assuming like this is big one, this is big two, and I got big one. I decided to move in this direction first. So I'll move in this direction. Now I know the next number won't be the smaller than this. So so suppose if this is a smaller number, smaller than smaller one. So I decided to move in this direction. Okay, this is big. Otherwise, if it is a smaller, then this will be big. So this is big. Big 3. Okay. And this is bigger than this number as well. But is this smaller than this? You can say smaller than this number. So this is okay. I mean, big 3. This is big 4. I mean, just I wanted to see if we can. And this is smaller. So I decided to go in this direction. A small number. Okay, so we can't move in this direction. So definitely I have two options. Either okay, this is a smaller number definitely, so we don't need to go. But what if it is big? Let me see. Oh no, I just took a small step, right? Smaller. I'm going to this direction. This is bigger than this and smaller bigger than this, so that means it will be bigger than this one as well. I'm just missing the corner cases, man. I'm just thinking like can we move in a forward direction and can I get the result? Just trying to do this problem. Come on, let me set up perfect correctly. So here we can say if we are not going to, this is big number, this is a smaller number, So it will decide to move this direction because this is big, and it could be either this one is big or this one. If it is bigger than this one it will be bigger, or this one will be bigger, or maybe this is bigger number. I'm missing some property. I mean, okay, for a given column and row, find global maximum. Pretty difficult. Global maximum for a given column or row. Find the global maximum. Global maximum. Okay, so global maximum in a row, that means it is bigger than all the numbers. So definitely it will be bigger than its left and right adjacent if we are row wise, if we are checking. And now we just need to check in the column if it is bigger than this, then that is okay. But what if it's global maximum, but it could be like it's not matching with this one and this one. These are not satisfying the criteria. Come on. Bro. Selecting the middle column, mid of the matrix. Okay. What is this, bro? Come on, just go. Start by selecting the middle column, mid of the matrix. Find the row index of the maximum element in that column. Compare this element with the left and oh, hold on. So you are going to get mid column, and selecting the middle column of the matrix, find the row index of the maximum element in that column. Oh, find the row index. Okay, so we'll start with mid column and we'll say find the row index, not row index, but find the index where the maximum element is found, row index. And okay, compare this element with its left and right neighbors, and top and bottom, definitely column will always be bigger than this. If a neighbor is greater, if a neighbor is greater, okay, so maybe left and right, move the left or right half, move to the left or right half of the column. I mean, this is, suppose this is a number that is bigger than, and now we got like here in this direction, and this is bigger column. So, or you can say this is the one that we are looking. But come on, man. Okay, so if we'll not so mid column, I feel like my brain is just, how they are coming up with solutions. I feel like it's not working for me. Let's watch video, bro. I'm not getting any solution for it.
So the problem that we're going to solve today is finding a peak element. The second, before watching this video, please go back in the playlist and watch the part 1 where we have figured out the peak element in a 1D array. So what does this particular problem state? It states that instead of a 1D array, it will be given a 2D array. And it is clearly stated that none of the two adjacent cells will be similar. What does that mean? If it is 2, it cannot be 2, it cannot be 2, it cannot be 2, it cannot be 2. So the problem is stating you're given a 2D matrix where none of the two adjacent cells can be similar. Your task is to figure out the peak element. In the part 1 of the problem, we had a 1D array where the peak element was an element that is greater than its left counterpart and it is greater than its right counterpart. So any element that was greater than its left and greater than its right was called as a peak element. Now in this particular problem, since a 2D matrix is involved, we will call an element a peak element only if it is greater than its left counterpart, greater than its right counterpart, greater than its top counterpart, and greater than its bottom counterpart. For an example, I can say 9 as a peak element. Why? Because it's greater than its top counterpart, greater than its right, greater than its bottom, greater than its left. Can I say 7 to be a peak element? Yes, I can say 7 to be a peak element. Why? Because 7 is greater than 3, the left, greater than 1, the top, greater than 2, the right. But on the bottom, we don't have anything. If you do not have anything, then it will be considered as -1. So the problem is clearly stating all the outer parts will be having -1. So thereby 7 can also be called as a peak element. Now in a 2D matrix, there can be simultaneous, like there can be multiple peak elements. Your task is to return the row and column of any one of them. Yes, any one of them. For an example, you decide to return this peak element. It is on the row 1 and it is at the column 1. So you'll have to return 1, 1. In case you decide that you have to return for this one, so it's on the third row and it's on the fourth column. So you'll have to return 3, 4. So this is what the problem is stating. Now, if this problem comes up in an interview, what is the first solution? The first solution that I can think of is like the extreme brute force. I scan through every element. Yes, I will be scanning through every element in a 2D matrix. And whenever I am standing at an element, I check for its left counterpart, check for its top, check for its right, check for its bottom. If it is greater than all the four counterparts, I will be calling that element as a peak element. So if I'm scanning through every element, what can be the worst possible scenario? I'll be scanning through everyone till the last element, isn't it? So it will be n cross m because that is the number of elements in the 2D matrix. And if I'm checking, whenever I'm standing on an element, I'm checking for 4 directions. So for every element, I'm checking in 4 directions. So can I say that the overall time complexity, the worst possible case will be n cross m cross 4? I can, right? Can I optimize this? I can, but by a slight margin. Now, for the best possible case, it will be, you just find out the first element to be the peak element. On an average, it will be somewhere in between. Only in the worst case scenario, the last possible element will be your peak element, and that is when this particular complexity will appear. I can only optimize the worst case scenario. I cannot optimize the best case. I cannot optimize the average case. I can definitely optimize the worst case scenario. How? Can I say, if I just return the largest element in the matrix, that will be my answer. Over here, 9, 9 is the largest. If I simply return 9, that will suffice. So if I go by the approach of finding the largest element in a 2D matrix, even in the best case, I'll have to scan through every element from the first to the last. Even in the average case, I'll have to scan through every element. Even at the worst case, I have to scan through every element. So the complexity will boil down to n cross m, but this will be a complexity for best, average, and the worst case complexity. So not that much of optimizations. Now, will this be accepted in an interview? No, they'll ask you to optimize this. So you've been asked to optimize n cross m. In this particular problem, we have a 2D matrix, and the total number of elements in the 2D matrix is n cross m. So the algorithm that we have figured out is equivalent to the search space, right? So we're searching for a peak element. And they're asking us to optimize. I cannot go through every element because if I've been asked to optimize n cross m, that technically means I have to trim down n cross m, which means I cannot go through every element. If I cannot go through every element, which means I have to delete, I have to skip some portion of the search space. And that is when you start thinking of algorithms. And that's when binary search comes in, because searching algorithm cannot go through everyone, have to skip. I think binary search is a potential candidate, and I start thinking in the direction of binary search. So before I move on to the binary search approach, please make sure that you should have seen the part 1 of this particular problem. In case you haven't seen it, or in case it has been a very long time, please pause this video right away. Find the link in the description, go back and watch it, get the intuition again back in your head, and then start watching it, because whatever intuition I've used in the part 1, I'll be using that over here. So if you remember, in part 1, I stated this thing that we're going to use binary search. And whenever we are standing on the mid, that mid will be the peak element only if it's greater than both of its left and right counterpart. And that is very obvious, because if you're standing at a peak and it's greater than left and right, that's a peak element. You stop. But in case this mid element was smaller than the right part, which means imagine you're standing here and the right part, this is the right part, so it's smaller than the right part, which means there is definitely a peak. There's definitely a peak on the right. Just think it as a mountain range. If you're standing here, the mountain has to go up before it goes down. Somewhere it will go down, because it is clearly stated outside of the array, it is -1. So even if it doesn't goes down, I'm very sure there will be a -1 at the outer portion of the array, because that is stated. Thereby, whenever I'm standing here and the right portion is actually greater, I eliminate the left half, right, in the part 1. And similarly, if the mid is smaller than the left, which means you're standing here, and this is your left, and it is smaller than the left, thereby I'm very sure that this is the inclination of the mountain. Thereby, you delete the right half. This is the intuition that we followed in part 1. We'll follow the similar intuition in part 2 as well. So let's try to solve it. What I'll try to do is, I have 6 rows. I'll take low to be standing at the 0th row and the high to be standing at the 5th row. I'll try to have the algorithm. What is mid for the first scenario? The mid will be 0 plus 5 by 2. That's the second row. Which is the second row? Can I say this is the second row? Tell me one thing. In the second row, which element has the highest possibility of being the peak element? Just think. Can I say whoever is the largest has the highest probability? Yeah, someone else might be, but who has the highest probability? Can I say 6? Definitely has the highest probability, because that's the largest element. So I'll be like, okay, Fine. Who's the max? Max is 6. Where is it? Here. Let's see if this can be a peak element. I stand at 6. It's greater. It's greater. It's greater. It's greater than all its 3 counterparts. But it's not greater than its left counterpart. Thereby, 6 cannot be a peak element. Thereby, 6 cannot be a peak element. Hence, you say that 6 cannot be a peak element. And you need to omit some portion because 6 can never be a peak element. And if you go on checking every element, you will not be able to optimize. So you don't go and check every element. You check for 6 and you say that this is not my peak element. Now the question arises. You took 0 and 5 to be low and high. Now you're standing at second column. Do you delete the left half or do you delete the right half? Is the question, because that is how we have been doing binary search. I started going back to this particular intuition and I think, hey, listen, why is 6 not a peak element? The only reason is there's someone on the left who is greater. There's someone on the left who is greater, right? Can I say if this is 6 and this is 7, is someone on the left who is greater? So maybe delete the right half. Yes, I go ahead and I say delete the right half. Yes, I delete the right half. The moment I delete, the high will, the high will come here. Yes, so low will be at 0, high will be at 1. Let me quickly erase it. So can I say low is at 0 and high is at 1? Thereby the mid will be 0 plus 1 by 2. That's 0. So if the mid is 0, who has the highest probability? Again, technically if I take the max element, that will always have the highest probability. And 4, yes. Now I see 4 is greater than its left. 4 is greater than 2. 4 is greater than its bottom. And at the same time, 4 is greater than its top. Thereby isolated. Again, technically if I take the max element, that will always have the highest. 0 plus 1 by 2, that's 0. So if the mid is 0, who has the highest probability? Again, technique 1. Thereby the mid at high is at 1. Thereby the mid will be 0 plus 1 by 2, that's 0. So if the mid is 0, who has the highest probability? Again, technically if I take the max element, that will always have the highest probability. And 4, yes. Now I see 4 is greater than its left. 4 is greater than 2. 4 is greater than its bottom. And at the same time, 4 is greater than its top. Thereby I say the max element 4 is my peak element, and we stop. Yeah, I know 9 could have been an answer, 7 could have been an answer, but we figured out an element and that is what we require. Just one, and that is where we stop. So part 1 was simple because it was a 1D array. It was easy to visualize. In the part 2,
Hey, what happened? Come on, man. Internet is not working over. Oh, it's working, bro. $11.28.
it was easy to visualize. In the part 2, you might have a couple of questions. The first one is, why are we taking the max element? And the second one might be, I'm not sure if you have this question. You said 6 is not the peak element, and you eliminated the right half, and you moved left on the basis that 7 is greater than 6. Taking that 7 is not the peak element.
You can also do a binary search on rows instead of column.
And you eliminated the right half and you moved left on the basis that 7 is greater than 6. Thinking that 7 might be your peak, but wait. 9 might be my peak, 7 might not be, because 7 is smaller than 9. So how are you managing this vertical alignment? Not vertical, how are you managing this alignment, whatever it is? So let me first answer this question. Why am I taking max? So whenever I'm taking an element, when do I call it a peak element? If it's greater than its top, greater than its bottom, left and right. Now if I'm taking max, in this case 6, am I very sure that it will be greater than its top and bottom? I'm very much sure about it. I'm left out with 2 cases, which is the left and the right. That's what I have to check. That kind of boils down to a 1D array case, because I don't need to check for these cases. Kind of boils down to a 1D array scenario, right? That is why I'm taking max, because I'm trying to go in the direction of 1D. Got it? Now your second question comes in. What's right, but then how do you manage 7, because it has a vertical alignment as well? This is what I'll now explain. Tell me one thing. If 7 is greater than 6, I'm saying 7 might be my peak according to the intuition. Thereby I'm going left. 7 might be my peak, but 7 is not. There's someone 9 which is greater. Tell me one thing. If 7 is greater than 6, which technically means, I repeat, which technically means 7 is greater than everyone here, right? Hence, 9 is also greater than everyone here, right? Hence, 9 is also greater than everyone here. Indeed, because if 7 is greater than 6, anyone greater than 7 will also be greater than this. Hence, this alignment is maintained. Even if you cancel off everyone, you're considering. I'm not saying 7 is definitely my peak. I'm considering it to be my peak. And if it is not, someone else is greater than 7. It will always be greater than its right part and the bottom part. I just need to check out the other parts. And eventually the algorithm will flow. You can take a bigger matrix, but just think on it. You'll start understanding it. The core is, if the intuition for the part 1 is crystal clear, you'll understand this as well. So as usual, I'll be writing code in pseudocode. I'm not sure why people on Twitter, on LinkedIn say that my course is in C++. I don't write code in C++. I write pseudocode. You have to understand this is pseudocode. This is not C++ Java. Please, if someone is saying I teach in C++, correct them. Tell them that Raj teaches in pseudocode version. And then you can write any code in any.
Okay, man. So we are going to sort it and apply binary search and then finding the max element in that particular column. Interesting. So we are boiling down the question. First thing is like you are maintaining. Okay, what I'll just revise it first. What is time right now, man? 9:31. So column, and you are taking low, high, great, and you are then considering mid, and you are finding max element, max in the mid. Okay, and whatever the max you are getting, and you are checking left, I mean my bad, right and left. How they are coming with solutions? I think for me it's completely new. I wasn't able to click, or it wasn't clicking in my mind, man. I need to practice a lot, then only I think I'll be able to detect the patterns. More I solve, more I'll able to get the patterns. So here like this is the max, so if it is max, that means it will be greater than this, and it will be greater than this. Just thinking symbol is good. Now okay, if this is bigger, let's take this is bigger number, so we move towards this. So low will be this plus 1 and this. So now suppose this is mid, we got somewhere mid, and that means I know for sure this is not the case. Then we need to check in this array, you can say, in this column location, and now we need to find out again some value. I need to find out mid value, what is mid here, and we need to check for mid what is the column value, and definitely whatever we are getting, whatever mid value that we are getting, it's greater than this one. It will be greater than this one and greater than this one in that along. But if you notice, this is right value. So this was mid. This is greater than mid. 1 minute, just I'm trying to build the intuition. Okay, that means this mid is bigger than this right? That means if this is bigger number, someone is bigger in this column, in this along this one, I mean in this column. If this is not the big, then definitely other elements will be some, if someone else is bigger, then that will be also bigger than this number. Yeah, so that's true. So it can be one possible option, but right now we are checking in the mid. If it is possible, we'll see. I mean, once we'll drill down in the back in this direction, otherwise we'll might see other one. But it's still pretty difficult, man. And literally, how someone is. Let me start it. Coding. Low will be 0. Okay, let me first write down n. N will be len of m rows n columns. So m will be len of mat, and n will be nothing but len of mat of 0. So low will be this, and high will be nothing but number of columns. So n, there are n columns, so n minus 1. While low less than equals to high, so we are applying binary search. Mid will be nothing but low plus high by 2. Great. So we got mid. So mid we can say like we find out the index of that. Okay. So right now you can say okay, then find max. So you can say, can I just say check if possible, and otherwise it returns plus or minus. If it is minus, then we'll do high minus 1, and if it's plus, then we'll go towards that. So I'm just checking result, or maybe move. So here we are going to pass mid, so that is our index column. So we need to check, and hey, that will be difficult, right? No, and I need to come up with another solution. So find max, let's say. I mean, yeah, that will be better. So define find max, and here we are going to give so self mid oh, he is giving order to someone. It's pretty bad. I don't like when someone is giving order to someone. I don't know. I feel like if someone is younger than me, I do not like to give order to them. Leave it, man. Sometimes people should have a little common sense from their end as well. Find max. Move, check if possible, mid. Oh. So mid we are giving that will be the mid will be the column, and I need to find it. Yeah, and matrix we can give. Sorry, my bad. I'm not focusing our what mid mat. So here what I'll do. I have mid, so I need to find out into that particular column. Find max. Okay. So can I use substring or what? I wanted to pass that as no. Let me do one thing. If you want to find out the max in that particular column, then you can say column will be the same, just we need to find out the row. So let me start with 0. Let me start. Column will be nothing but mid, or for I, oh man, why I'm doing this? So rows are nothing but here, if you see mat of mat, yeah, in range. And if, let me say row is -1, row equals to 0, so I'll do my bad, len of matrix and something. I'm just I that's why I avoid to write code directly. I prefer to write it on white paper, but I don't know why I chose this option. Okay, so if I know I'll make mistakes, I think so. If you can say row equals to 0, oh my bad, so it will be like something, row is 0. So if mat of column, sorry my bad, row and column, and yeah, is greater than definitely it will be greater than that only, right? Mat of row and column, simply what needs to be done, row you can say is nothing but I, and finally return row and col. So we'll get the R and C, not this, find max self dot, oh man, find max, and here we are going to give mid matrix and mid. So we got this max row and column. Now what needs to be checked, what we need to check? So we have the particular row and particular column, and the particular row and particular column, we got this, and now we need to check its previous one. Oh, let me do one thing, it will be better. Left value will be, you know what, if R equals to -1, I mean what are you doing? Left and right. So if R -1, I mean left one, so index row is -1. Bro, what are you doing? You need to find out row and column. I mean, yeah. So if C -1 is less than 0, that means what? You can say left value will be -1. Else you can say it will be the thing but mat of row R and C -1. Okay, I think I'm doing correctly. Right will be -1 if C plus 1 greater than 0, greater than n, greater than or equals to m, number of, hey, what you did here? I feel somewhere I made mistake, not m, n. That means you are doing this. Else matrix of row R minus C plus 1, I mean, yeah. So if mat of row, no, R and C is greater than left and mat of R and C is greater than right. Return R and C, not class. EL if mat of row is greater than row and column is greater than left. I need to check this. If left is greater than mat of row, what the row and column, that means man I did something funny here. EL if I'm just doing something that is not acceptable here. So definitely we can say we need to move. If left one is bigger, then high will be mid minus 1, else what is time right now? That's the big else low will be mid plus 1, and finally if it is not, then okay, what is let me do one thing. If it is not the case, return -1 and -1. I don't need this. So let me debug it before submitting it. M is nothing but matrix of number of rows, and this is nothing but matrix of zeros. Calls low is 0, high is pointing to the basically columns number low less than equals to high. Mid we calculated low plus high by 2, and then we provided mat and mid. This is the element, and find the max for it. What is the max in this row, in this column particularly, not row. So row we decided like it is earlier 0, first row, or 0th row we calculated, and now we started looking for 1 and len of matrix, that will be nothing but you can say m, and we started from 1 onwards, so the 0 we already taking. So we are comparing if matrix of I represents row number, and column we already got mid. So column, what is this column? Column mid we kept it, okay, so no problem. Row I index and matrix of row and column we are comparing, like if it is bigger than this, then we need to update the row value to I, and finally we are returning row and column. So I think everything is good so far. And here if we are checking if column that we received, if we are reducing that means to find the left value or the left value of it, 1 minute. Column will be reduced to get the, because row will be the same, we are looking for the left and right. So column -1, if we are checking, if it's less than 0, that means we are hitting the boundary condition, so we can say -1 will be the value left out. Else matrix of row will be the same, column will be column -1, else and right will be -1 if c plus 1 is greater than n number of columns. So that means if it is greater than or equals to, that means r c plus, else r c plus 1. Okay, so everything is looking good to me. Let me see. Come on. High referenced before. Oh man, I always do height instead of height. HEIGST is correct, right, for height. But still I need to find out if it will. Perfect. So I solved it before 9:49. I means here definitely I solved the solution. But it's pretty. Okay, that's why I avoid to write the code directly in the node editor. First I try to check all the corner cases, then I'm solving it. but so far going good. And how many problems we solved so far? Though it's medium problem, but I took a lot of time. Matrix median. Okay, so tomorrow we have one more problem, and definitely I'm gonna to attempt these problems again, and especially the one where I stuck. Let me write down a note. Bro, what are you doing? You are unable to solve it without watching the editorial video. Are you fucking crazy? Where is your brain? I'm little harsh to me, but normally people say like don't be harsh to yourself. I'll avoid this word. Brain. My brain is in the hospital. I'm so bad, man. Yeah, but good. At least we are making progress, and that is very important. And I'm focusing on one or two problems. It's easy for me to track. And that's all for the day. And now I'm going out for dinner. So bye bye. We'll see you tomorrow. Thank you so much. And where I stop stream. Actually, you might be hearing lot of background noises actually. So that's what. The room is also not like some. My neighbor can hear me properly from window, from this window. But so, no, nothing here. Privacy is myth, and that's